Hi, in this video from Unit 1 of Basic Chemical Engineering course, I am going to discuss problems related to unit conversions. To start with, these are the basic unit conversions we require for solving problems related to the first unit. It is expected that the student must remember these units so that they can use that for solving various unit conversion problems. By solving more problems, you can remember these values without any much difficulty. So instead of reading this again, you can take a screenshot of this particular slide for easy reference. Okay, problem 1. So we are asked to convert 18.5 centimeter to inches. So from the data table, let's list out the necessary units. Here we need a relation between centimeter and inches. From the table, I just cropped this and placed it here. You can recall from the table. So 1 inch is equal to 2.54 centimeter. We have to convert centimeter to inches, so I am taking a relation that connects inch and centimeter here. In this basic chemical engineering course, we are going to follow unique table way of solving this problem to avoid mistakes during solving this problem. So you are expected to draw a table like this, and we list the number in the first cell and we write the units of the corresponding term. So 18.5, then centimeter is written here. Now what I am supposed to do is, I have to find the relation that connects centimeter and inches. In this case, it is 1 inch and 2.54 centimeter. So to cancel the centimeter, I have to replace the respective term in the denominator here, and the unit that has to come should be in the numerator. This should be the way I have to enter the data. Being the first problem, I am explaining in detail. I repeat again, you have to form a table. In the first cell, you have to write the numerical value, followed by next column, you have to write the unit of the given value. So in this case, it's centimeter. Next, we have to write the relation which connects the centimeter and inches. Since centimeter is here, we have to write centimeter in the denominator so that centimeter and centimeter will cancel. We will get inches in the numerator. So as per the table data, so 1 inch is equal to 2.54 centimeter. You can ask me, sir, why 1 inch is kept on in the top row and 2.54 centimeter in the bottom row? Since we have to cancel centimeter and replace it with inches, I am writing like this. So 2.54 centimeter in the denominator, 1 inch in the numerator. This relation is taken from this table. This centimeter and the numerator centimeter I can cancel. So this both can be cancelled. So it is removed. The remaining term we can combine and we can proceed with the calculations. So it's going to be 18.5 divided by 2.54 inch, which gives us 7.2 inches. So we converted 18.5 centimeter to inches, that is 18.5 centimeter is 7.28 inches. The same method of solving we're going to use for different questions now. Let's move on to next question. In this question, we are asked to convert 997 kg per meter cube to gram per cc. Kg per meter cube is mass by volume, which is actually density. So 997 kg per meter cube to gram per cc. The first step is to identify the respective relations from the data table, which you are expected to remember during the examination. Now we have to convert, first term is kg here. So kg to gram we have to convert. So as per the relation, 1 kg is equal to 1000 gram. Next we have meter cube here. We have to convert the meter cube in the denominator to cc. That is, cc is cubic centimeter, which is actually equal to 1 ml. So 1 ml and 1 cc are same. In this problem, we have asked to convert meter cube to cc. So I am going to convert first meter cube to liters. From the liter, I will convert to ml. Let's see how we can solve this problem. As we used this table format for the previous problem, in this problem also we are using the same method. You can use different methods also, but this method is simple and it can help you solve the problem without any mistakes. So first step is to fill the given value. So 997, the numerical in the first column. Next we are writing the unit. So the numerator has kilogram. So I have written kilogram here. I have written meter cube in the denominator here. Now we have to fill this column with respective relations which we need to convert. In this case, we have to convert kilogram to gram. So kilogram gram relation is this, 1 kg by 1000 gram. So I have to fill this value here. Now kilogram should be in the denominator or in the numerator. So now to cancel kilogram and to bring gram here, I have to put the kilogram in the denominator. So 1 kg in the denominator, which is equal to 1000 gram in the numerator. Next we move to meter cube. So relation between meter cube and liter is there. So 1 meter cube is equal to 1000 liter. Again, to cancel the meter cube, I have to write in the opposite side. So meter cube should be here, liter should be here. So it's going to be 1 meter cube divided by 1000 liter. So 1 meter cube is 1000 liter as per the data. Now you can see the meter cube is here. So I have to cancel this. So I kept the meter cube in the topmost row. Now the problem is not solved because now we inserted the relation between meter cube and liter. But in the question we are asked to calculate Cc. So as I already told you, Cc is equal to ml. So I am filling the relationship between liter and ml here. 1 liter of solution has 1000 ml of solution. 1 liter of any liquid will have 1000 ml. Hence I have to cancel liter. So I am writing liter in the numerator, and the denominator I am writing the respective ml term. So 1000 ml. Now we filled all the data. One by one we will cancel the units whichever we are planning to do. First stage we have kilogram and kilogram. We can cancel this kilogram. So we removed it. Then we have meter cube. So we'll remove the meter cube because this and this meter cube will get cancelled. We removed it. Now we are left out with liter and liter here. So I can cancel the liter and liter also. Now no more any terms where we can cancel out here. Only the numericals we can cancel. Before cancelling the numerical, I want to write everything as a one equation. So in the numerator I am multiplying and writing here. So 997 into 1000. Denominator has nothing, only 1000 and 1000. So 1000 into 1000. Respective unit is gram per ml because only gram is left out here. Ml is left out here. So gram per ml. When we solve this, we will get 0.997 gram per ml. As I already told you, gram per ml is equal to gram per cc. 1 cc is equal to 1 ml. Moving on to next problem. So we are asked to convert 2.5 into 10 power 7 centimeter per hour square to meter per second square. As I already told you, the first step is to write the respective relation. So now we have centimeter here and we have to convert to meter. We have hours here and we have to convert the hours into seconds. Now let's list the respective relation from the table. So 1 meter is equal to 100 centimeter. We know that we have to find a relationship between centimeter and meter. So from the table 1 meter is equal to 100 centimeter. And we know 1 hour is equal to 60 minutes and 1 minute takes 60 seconds. So here we have to convert from hour to minute, from minute to second. So hope you can get this. We'll move on to the next step, that is drawing the table. Now in the table, the first cell I will fill with the numerical value. Second column I will fill with the respective units. In this case centimeter and hour square. Centimeter in the numerator and the hour square in the denominator. So hence I fill these values respectively here. Now first cell I will write the relationship for the centimeter. So the relationship between centimeter and meter is 1 meter is equal to 100 centimeter. So I have to fill either meter or centimeter here. Since I have the centimeter in the numerator here, I am filling the value of centimeter here. So 100 centimeter is equal to 1 meter. Now let's fill the value of next unit, that is hour square. You can see that the hour has to be squared here. So 1 hour is equal to 60 minutes. This is a relationship. I have to keep the hour in the numerator so that the hour will get cancelled. Also this is hour square, hence I have squared the value. So 1 hour square is equal to 60 minutes square. Hope you understood that the square is for both 60 as well as minute also. As per the question, we cannot stop with hour to minute. We have to convert the minute to seconds also. So 1 minute is equal to 60 seconds. Since we have minute square here, so here also I have to replace accordingly with 1 minute square. So 1 minute square is equal to 60 seconds square. We students make a mistake of forgetting the squared value. So make sure during exam you are putting the square accurately here. Now next step is to cancel the terms which are uniform in the numerator and denominator. Now we have centimeter here and the centimeter here. So we can cancel these centimeters. So it has gone. Next we have is hour square and hour square. We can cancel the hour square. Now we left out with minute square and minute square. We can cancel that. So before that the square will be there for 60. You have to remember that. So we can cancel these minute squares. So once we cancel, we are left out with these values. So you can see only unit present in the numerator is meter. And in the case of denominator, we have only second square, which is the one we are looking for. So let me compile all these things to a one single equation. It comes to be, in the numerator, we have only 2.5 into 10 power 7 term. And it is just 1 meter. So I am writing 2.5 into 10 power 7 as a numerator. Coming to the denominator, we have 100 multiply by 60 square, so 60 square here, then multiply by again 60 square. So I have the unit meter per second square here because meter is here, second square is squared here, second is squared here. So I have meter per second square. When I multiply, I can find the value which comes to be 1.93 into 10 power minus 2 meter per second square.